Welcome to the next session of Strength of Materials. In this session, I am discussing about strain energy for composite bars. In the previous lectures, we have already discussed about the various formulas of strain energy for various types of loading, for gradual, suddenly applied load or suddenly applied load with impact. So in this session, what is different is we are going to study about composite bars, which means there will be one bar inside the other. So it is going to apply a different kind of resistance to the load which is applied on it, and hence the strain will be different on the body. And when the strain is going to be different from a normal bar to a composite bar, obviously you will find a difference in the energy which is stored in the system. So let's get started. We'll start with gradually applied load on a composite bar. As you can see in the diagram, there are two bars. The internal one is labeled as 1 and the external bar is labeled as 2. There is a load P applied on this bars and the length of the bar is L. So the external force P, which is acting on the composite bar here, is actually shared by both the bars. So I can say that total load P will be P1 plus P2, where P1 is the load borne by the first bar and P2 is the load borne by the second bar, or I can say it is the amount of resistance which is provided by the bar to the load applied on it. So when I write here in the form of resistance, I can say it is sigma 1 A1 plus sigma 2 A2. Let me mark this as equation 1, which I am going to use. Now let's talk about the total strain energy on the body. Let me call it as U. This will be U1 plus U2, which is the strain of the body 1 plus the strain energy of the body 2. So when I write the formula of U, as we already know, it is sigma square AL upon 2E. Now when I am talking about the first bar, let me write this as sigma 1, area as A1 and E as E1. When I talk about the second body, this will be sigma 2 square A2 L upon 2E2. Now this is another formula which I am going to use for the body when I am solving the numericals. So this is the formula for strain energy. Now let's talk about the change in length of each bar. Now when you talk about the change in length, if you observe carefully, this is going to remain the same because the initial length is same for both and the load borne by them is shared. Here for composite bar, the change in length is same. Now when I say the change in length is same, I will have delta L, which is the total change in length, will be delta L1, which will be equal to delta L2. This is the change in length for the first one and this is the change in length for the second bar. So here I can also write this as delta has a formula PL upon EA or sigma L upon E. So I can write here sigma 1 L upon E1 is equal to sigma 2 L upon E2. Now since the strain is equal, this is another formula which I can use, say when I am solving a numerical. Now let's talk about the last part in this, that is the work done by gradually applied load. When I say work done by gradually applied load, this will be equal to the total strain energy stored in the composite bar, because how much ever amount of work is done on the body, that will be converted into energy and stored in the bar. So I can write here it is equal to total strain energy in the composite bars. Now when you look at this, you will have to recollect a formula of a graph, that is load versus displacement. When I talk about load versus displacement, if you recollect, the graph for gradually applied load is this way. So as you keep on increasing your load, your change in length is going to happen. So when I say this way, this is the area of the body. If you look at the area over here, this is a triangle. So the area of triangle is given as half base into height. So I'm using the two terms, half P into L is equal to strain energy is U1 plus U2. So U1 plus U2 is known. If you want, you can substitute them. but I'm just writing for you that this is another formula which you can use for work done in the body equal to the strain energy stored in the body. So these are the four formulas which you can use while solving of your numericals for gradually applied load in case of composite bars. Next, let's go for suddenly applied load. When I talk about suddenly applied load, I'm going to use the equation P is equal to P1 plus P2. So this will be sigma 1 S. Don't forget to write this S. S stands for suddenly applied load. A1 plus sigma 2S A2. This is the formula. Let me mark this as equation 5. I'm writing in continuation, so I'm using equations one by one. Next, when I talk about the strain energy, just use the formula US is equal to U1S plus U2S. This is the strain energy for body 1 plus the strain energy for the body 2. Formula will be sigma 1S square A1L upon 2E1. E is the Young's modulus and E1 stands for Young's modulus of the first material, and for the second material I am going to use E2. So this is a self-explanatory formula now because you already know this from the previous one. Similarly, my change in length is also going to be same. It will be delta Ls is equal to delta L1S, which is equal to delta L2S. So this can also be written as sigma 1SL upon A1 is equal to sigma 2SL upon A2. Now here I am writing S again and again because I am talking about suddenly applied load. So this 2 can be your equation 7 because they are just the same. So I am writing all for the two of them. And the last equation, as we just discussed, was work done will be equal to the total strain energy stored in the body of the composite bar. Now when I talk about suddenly applied load, if you recollect the graph, this is load and this is my change in length. Suddenly applied load is going to be something like this. Your load is suddenly applied and that will show your change in length. Now this is the area under the graph. So when I talk about a rectangle, it is the product of the two sides, L into B, that is length into breadth. So I'll have P into delta Ls is equal to the total strain energy, which is U1 plus U2. So this becomes my formula 8. Now here you must have seen that the formulas are actually the same except for this point. The formula has changed a bit, and apart from that I am using S everywhere because it is about suddenly applied load. Now one more relation which you should remember, that is the relation between the stress due to suddenly applied load and gradually applied load. So the stress due to suddenly applied load is said to be twice that of gradually applied load. So this is something which you need to recollect while solving numericals. Now I can write this sigma as P by A. So just a formula. Remember this while solving numerical. This will be very helpful. Next we will go for suddenly applied load with impact. Here I'll have P again. That is the load. Total load applied on the body is resisted by both the bars. So P1 plus P2. This can be written as sigma 1 I A1. Be careful. Here instead of S, I am using I because it is suddenly applied load with impact. So just a change in notation. And here it will be sigma 2I A2. Let me mark this as equation 10. Then let's talk about strain energy. Total strain energy stored in the composite bar. UI will be U1I plus U2I. That is the total strain energy of body 1 plus body 2. This can be written as sigma 1 I square AL upon 2E1, area will also be A1, plus sigma 2 I square A2 L upon 2E2. You can mark this as equation 11, which can be used again. And then I talk about change in length. It will be equal. So I'll have delta L will be delta L1I, which will be equal to delta L2I. This can also be written as sigma L upon E for the first one. So sigma 1I L upon E is equal to sigma 2I L upon E2. Let me mark this as equation 12. Last we'll talk about the work done. Work done is equal to total strain energy. So when I talk about total strain energy, it is very simple because it is just the formula which I wrote here. So from here I'm going to directly copy. It is U1I plus U2I. Now let's talk about the work done with impact. For work done with impact, if you recollect the formula a bit, here the formula was P into H plus delta Li. The reason is for suddenly applied load with impact, if this is the collar on which the load is applied and the load is at some height over here. Say the end is fixed and at some height you have your load and it suddenly falls from here to here. The distance is h. So delta Li is the strain, but you also need to add this h over here, which is the distance or the height from which your load falls on the body. So say the load over here is P. That is the same load which I am marking here. So you can write here, this is equation number 13. This will be useful for solving of your numerical again. Now one more thing which I need to add here is the relation between stress due to suddenly applied load with impact and gradually applied load. So you should know a relation, that is sigma I is sigma into 1 plus root of 1 plus 2AEH upon PL. I think we have also discussed this before. If you can just go through the previous lectures. Now here I can just write this as P by A into 1 plus root of 1 plus 2AEH upon PL. Just a little modification to this formula. This is the formula of sigma I. So with this I am going to end this session. This was all about the formulas which we are going to use for solving of load applied on composite bars and the strain energy calculation along with the work done, stress, load, everything on the body. In the next session, we will discuss about the numerical on this topic. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.